To address the need for automatic power load switching, particularly with dryer priority, several solutions are available. These solutions range from electrical panels with load shedding capabilities to smart home hubs and dedicated load balancer devices. Firstly, consider electrical panels equipped with load shedding. Siemens Centron load shedding panels, for instance, provide real-time load monitoring. These panels automatically shed non-essential loads such as dryers or hot water tanks when the overall electrical demand exceeds the panel's capacity. Eason Power Expert panels also offer load shedding features, allowing users to prioritize essential loads over non-critical ones. Secondly, smart home hubs, used in conjunction with IFT, can be employed for this purpose. Amazon Echo Plus, specifically the second generation and above, can trigger IFT automations. These automations enable switching power between devices based on specific conditions. Google Nest Hub, similar to Echo Plus, facilitates IFT automations, providing another avenue for managing power loads within a home. Thirdly, dedicated load balancer devices provide a more focused solution. The load controller LB-100 automatically switches between loads based on preset amperage limits and priority settings. Aqara Smart Plug Hub with submeter monitors power consumption and can switch between plugs based on preset rules or manual control, offering flexibility and customization. Fourthly, power management software provides a software-driven approach to load management. Wattspot Smart Energy Manager offers intelligent load management and prioritization through software and connected devices. Moen U by Moen Smart Water Assistant allows for remote control of hot water tanks and can be integrated with load balancing solutions to optimize power usage. To set up automatic switching with dryer priority, follow these general steps. 1. Install the selected load switching device or software. 2. Set the priority of the loads, ensuring the dryer is configured with higher priority than the hot water tank. 3. Configure the device or software to monitor power consumption and automatically switch between loads when the total demand approaches or exceeds the electrical system's capacity. 4. Verify that the dryer has sufficient power, meaning enough amperage, available to operate simultaneously with other essential loads without causing any breakers to trip. When selecting a solution, several factors should be considered. Assess the total electrical load of all appliances that will be managed by the system. This ensures the chosen device or panel has sufficient capacity. Evaluate the ease of installation and configuration. Some solutions may require professional installation, while others offer simpler, DIY setup options. Determine the level of customization required. Some systems offer more granular control over load priorities and switching parameters than others. Check for compatibility with existing smart home ecosystems. If the home already uses a particular smart home platform, choosing a compatible load switching solution can simplify integration. Always consult with a qualified electrician when installing or configuring load shedding or power management systems to ensure safety and compliance with local electrical codes. Load calculations are a critical aspect of electrical work. Load calculations determine the required capacity of the electrical service, feeders, and branch circuits in a building. These calculations are based on the anticipated electrical demand of the building's loads, including lighting, appliances, heating, and cooling equipment. Accurate load calculations are essential for ensuring the electrical system can safely and reliably supply power to all connected devices. The National Electrical Code, NEC, provides detailed guidelines for performing load calculations. These guidelines take into account various factors such as the type of occupancy, the size of the building, and the types of loads that will be connected. The NEC specifies different methods for calculating loads depending on the application. For example, the standard method is used for most residential and commercial buildings, while the optional method may be used for certain dwelling units. The standard method involves calculating the general lighting load based on the square footage of the building. The NEC specifies a minimum lighting load in volt amps per square foot for different types of occupancies. For example, a dwelling unit typically requires a lighting load of 3 volt amps per square foot. Small appliance branch circuits are required in kitchens, dining rooms, and similar areas. The NEC requires a minimum of 220 amp small appliance branch circuits in these areas. Each small appliance branch circuit is assigned a load of 1500 volt amps. Laundry branch circuits are required for laundry areas. The NEC requires at least 120 amp laundry branch circuit. Each laundry branch circuit is assigned a load of 1500 volt amps. For appliances such as dishwashers, disposals, and ranges, the NEC provides specific rules for calculating the load. These rules take into account the nameplate rating of the appliance and the duty cycle. For example, the NEC allows demand factors to be applied to the nameplate rating of ranges, depending on the number of ranges installed. Heating and cooling equipment, such as air conditioners and heat pumps, can represent a significant load in a building. The NEC requires the load to be calculated based on the nameplate rating of the equipment. The largest motor is typically the air conditioner motor. After calculating the loads for all of the individual components of the electrical system, the total load is determined by summing the individual loads. The NEC allows demand factors to be applied to certain loads, such as lighting and appliances, to account for the fact that not all loads will be operating at the same time. Demand factors are based on statistical data and represent the percentage of the total connected load that is expected to be in use at any given time. The calculated load is used to determine the required size of the electrical service, feeders, and branch circuits. The NEC specifies the minimum ampacity of conductors based on the calculated load. Conductors must be sized to carry the calculated load without overheating. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect conductors from overloads and short circuits. The NEC specifies the maximum size of overcurrent protection devices based on the ampacity of the conductors. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. The length and size of conductors are selected to minimize voltage drop. Grounding is the process of connecting the non-current carrying metal parts of an electrical system to earth. Grounding provides a low impedance path for fault current to flow back to the source, which helps to protect people from electric shock. The NEC specifies the requirements for grounding electrical systems. Bonding is the process of connecting the non-current carrying metal parts of an electrical system together to create an electrically conductive path. Bonding helps to ensure that all metal parts are at the same voltage potential, which reduces the risk of electric shock. The NEC specifies the requirements for bonding electrical systems. Electrical safety is a critical aspect of electrical work. Electricians must be knowledgeable about electrical hazards and safety procedures. Electrical safety practices include using personal protective equipment, such as gloves and safety glasses, de-energizing circuits before working on them, and testing circuits to verify that they are de-energized. The NEC provides guidelines for electrical safety. Arc flash is a dangerous electrical hazard that can occur when a short circuit creates a high-energy arc. Arc flash can cause serious burns, injuries, and even death. Electrical equipment must be designed and installed to minimize the risk of arc flash. The NEC provides guidelines for arc flash protection. Electrical inspections are performed to ensure that electrical installations comply with the NEC and other applicable codes and standards. Electrical inspectors are responsible for verifying that electrical work is performed safely and correctly. Electrical inspections help to prevent electrical fires, injuries, and other hazards. The NEC is updated every 3 years to reflect changes in technology and best practices. Electricians must stay up to date on the latest changes to the NEC in order to ensure that their work complies with the code. Continuing education courses and industry publications can help electricians stay informed about the NEC. The authority having jurisdiction, OJ, is the organization responsible for enforcing the NEC and other applicable codes and standards. The AHJ may be a local, state, or federal government agency. Electricians must comply with the requirements of the AHJ. Wiring methods are the techniques and materials used to install electrical conductors. The NEC specifies the allowable wiring methods for different applications. Common wiring methods include conduit, cable, and surface raceway. Conduit is a rigid metal or plastic tube used to protect electrical conductors. Conduit provides excellent mechanical protection for conductors and is often used in commercial and industrial applications. Cable is a factory assembly of two or more conductors enclosed in a sheath. Cable is commonly used in residential and light commercial applications. Surface raceway is a metal or plastic channel used to route and protect electrical conductors on the surface of a wall or ceiling. Surface raceway is often used in retrofit applications where it is not practical to run conductors inside walls or ceilings. Boxes and enclosures are used to protect electrical connections and devices. The NEC specifies the requirements for boxes and enclosures. Boxes and enclosures must be sized to provide adequate space for conductors and devices. Boxes and enclosures must be made of materials that are suitable for the environment in which they will be installed. Conductors are the wires that carry electrical current. The NEC specifies the types of conductors that can be used for different applications. Conductors are typically made of copper or aluminum. Copper conductors have lower resistance than aluminum conductors, but aluminum conductors are lighter and less expensive. The ampacity of a conductor is the amount of current that the conductor can carry safely. The NEC specifies the ampacity of conductors based on their size, material, and insulation type. Terminations are the points where conductors are connected to electrical devices. The NEC specifies the requirements for terminations. Terminations must be made in a way that provides a secure and reliable electrical connection. Terminations must be protective from corrosion and mechanical damage. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect conductors from overloads and short circuits. The NEC specifies the maximum size of overcurrent protection devices based on the ampacity of the conductors. Ground fault circuit interrupters, GFCIs, are used to protect people from electric shock. GFCIs detect ground faults, which are unintentional electrical paths between a current-carrying conductor and ground. When a GFCI detects a ground fault, it quickly shuts off the power to the circuit. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters of size are used to protect against electrical fires. ASIs detect arc faults, which are dangerous electrical arcs that can occur in damaged or worn wiring. When an ASI detects an arc fault, it quickly shuts off the power to the circuit. ASIs are required in many locations, such as bedrooms and living rooms. Surge protection devices, SPDs, are used to protect electrical equipment from voltage surges. Voltage surges are brief spikes in voltage that can damage or destroy sensitive electronic equipment. SPD divert voltage surges away from the equipment they are protecting. SPD are recommended for all electrical systems, especially those that serve sensitive electronic equipment. Electrical maintenance is the process of inspecting, testing, and repairing electrical equipment to ensure that it is operating safely and reliably. Electrical maintenance should be performed on a regular basis by qualified electricians. Electrical maintenance can help to prevent electrical fires, injuries, and other hazards. Troubleshooting is the process of identifying and correcting electrical problems. Troubleshooting requires a thorough understanding of electrical principles and systems. Troubleshooting techniques include visual inspection, voltage testing, and continuity testing. Electrical repairs should only be performed by a qualified electrician. Electrical repairs must be performed in accordance with the NEC and other applicable codes and standards. Electrical repairs must be performed safely and correctly to prevent electrical fires, injuries, and other hazards. Energy efficiency is the process of reducing the amount of energy used to perform a task. Energy-efficient electrical equipment can save money on electricity bills and reduce the environmental impact of electricity generation. Energy-efficient electrical equipment includes LED lighting, energy-efficient appliances, and smart thermostats. Renewable energy is energy that comes from natural sources such as sunlight, wind, and water. Renewable energy sources are sustainable and do not produce greenhouse gases. Renewable energy technologies include solar panels, wind turbines, and hydroelectric dams. Distributed generation is the generation of electricity at or near the point of use. Distributed generation technologies include solar panels, wind turbines, and generators. Distributed generation can reduce the reliance on the electrical grid and improve the reliability of the electrical supply. Smart grids are electrical grids that use advanced technology to improve the efficiency, reliability, and security of the electrical system. Smart grids include smart meters, which provide real-time information about energy consumption, and advanced control systems, which can optimize the flow of electricity. The future of electrical technology is likely to be characterized by increased automation, connectivity, and intelligence. These trends will lead to more efficient, reliable, and sustainable electrical systems. New technologies, such as artificial intelligence and machine learning, will play an increasingly important role in the design, operation, and maintenance of electrical systems. Electric vehicle charging infrastructure is also becoming increasingly important as electric vehicles become more popular. Electrical engineers and electricians will need to be knowledgeable about these new technologies in order to meet the challenges of the future. Load diversity is the concept that not all electrical loads in a building will be operating at their maximum demand at the same time. This allows for the electrical service and distribution system to be sized smaller than the sum of all the individual loads. Demand factors are used to account for load diversity when performing load calculations. The specific demand factors that are used will depend on the type of occupancy and the types of loads that are present. For example, a dwelling unit will typically have a lower demand factor than a commercial building due to the different patterns of electrical usage. It is important to note that demand factors are based on statistical data and represent the average expected load. The actual load at any given time may be higher or lower than the calculated load. Therefore, it is important to use conservative demand factors to ensure that the electrical system has sufficient capacity. The power factor is a measure of how efficiently electrical power is being used. A power factor of 1.0 indicates that all of the electrical power is being used to do work. A power factor of less than 1.0 indicates that some of the electrical power is being wasted. Low power factor could be caused by inductive loads such as motors and transformers. Power factor correction can be used to improve the power factor and reduce energy waste. Power factor correction typically involves adding capacitors to the electrical system to offset the effects of inductive loads. Harmonic distortion is a type of electrical pollution that can be caused by nonlinear loads such as electronic devices and fluorescent lighting. Harmonic distortion can cause a variety of problems, including overheating of electrical equipment, malfunctioning of electronic devices, and increased energy losses. Harmonic filters can be used to reduce harmonic distortion. Harmonic filters typically consist of inductors and capacitors that are tuned to specific frequencies. Transient voltage surge suppressors (TVSSs) are used to protect electrical equipment from transient voltage surges, also known as voltage spikes. Transient voltage surges can be caused by lightning strikes, switching of electrical equipment, and other events. TVSSs divert transient voltage surges away from the equipment they are protecting. TVSSs are available in a variety of types and sizes, and they should be selected based on the specific application and the level of protection required. Electrical safety audits are performed to identify potential electrical hazards and to ensure that electrical systems are in compliance with safety codes and standards. Electrical safety audits should be performed on a regular basis by qualified electrical safety professionals. Electrical safety audits can help to prevent electrical fires, injuries, and other hazards. Lockout/tagout procedures are used to protect workers from electrical hazards during maintenance and repair work. Lockout/tagout procedures involve de-energizing electrical equipment and placing locks and tags on the equipment to prevent it from being accidentally energized. Lockout/tagout procedures are required by OSHA and other regulatory agencies. Electrical safety training is essential for all workers who work with or around electrical equipment. Electrical safety training should cover topics such as electrical hazards, safety procedures, and the use of personal protective equipment. Electrical safety training should be provided by qualified electrical safety professionals. The use of personal protective equipment, PPE, is essential for protecting workers from electrical hazards. PPE includes items such as gloves, safety glasses, and arc-rated clothing. The type of PPE that is required will depend on the specific task being performed and the level of electrical hazard present. Electrical codes and standards are developed by organizations such as the National Electrical Code, NEC, the National Electrical Manufacturers Association, NEMA, and the Institute of Electrical and Electronics Engineers, IEE. Electrical codes and standards provide guidelines for the safe and proper installation, operation, and maintenance of electrical systems. Electrical codes and standards are constantly evolving to reflect changes in technology and best practices. The electrical industry is constantly changing, with new technologies and techniques being developed all the time. It is important for electrical professionals to stay up to date on the latest changes in the industry in order to provide the best possible service to their customers. There are a variety of ways to stay up to date on the latest changes in the electrical industry, such as attending conferences, reading industry publications, and taking continuing education courses. Load management is a strategy used to optimize the use of electrical power by shifting or reducing loads during peak demand periods. This can help to reduce energy costs and improve the reliability of the electrical grid. Load management techniques include demand response programs, which provide incentives for customers to reduce their electricity usage during peak demand periods, and energy storage systems, which can store energy during off-peak periods and release it during peak demand periods. Microgrids are small-scale electrical grids that can operate independently of the main electrical grid. Microgrids can be used to provide power to a single building, a campus, or a community. Microgrids can improve the reliability of the electrical supply and can also be used to integrate renewable energy sources into the electrical grid. Energy storage systems are devices that can store electrical energy and release it later when it is needed. Energy storage systems can be used to improve the reliability of the electrical grid, to integrate renewable energy sources into the electrical grid, and to reduce energy costs. There are a variety of types of energy storage systems, such as batteries, pumped hydro storage, and compressed air energy storage. Smart homes are homes that are equipped with technology to automate tasks and improve energy efficiency. Smart home devices can be controlled remotely using a smartphone or tablet. Smart home devices include smart thermostats, smart lighting, and smart appliances. Building automation systems, BASs, are systems that are used to control and monitor the mechanical, electrical, and plumbing (MEP) systems in a building. BAS can be used to improve energy efficiency, to improve occupant comfort, and to reduce operating costs. Electrical system design is the process of planning and designing electrical systems for buildings and other facilities. Electrical system design involves calculating electrical loads, selecting appropriate equipment, and ensuring that the electrical system complies with all applicable codes and standards. The electrical system installation is the process of installing electrical equipment and wiring in buildings and other facilities. Electrical system installation must be performed by qualified electricians in accordance with all applicable codes and standards. Electrical system testing and commissioning is the process of verifying that electrical systems are operating properly and that they comply with all applicable codes and standards. Electrical system testing and commissioning should be performed by qualified electrical testing technicians. Electrical system maintenance and repair is the process of inspecting, testing, and repairing electrical equipment to ensure that it is operating safely and reliably. The electrical system maintenance and repair should be performed on a regular basis by qualified electricians. Electrical safety is a critical aspect of electrical work. Electricians must be knowledgeable about electrical hazards and safety procedures. Electrical safety practices include using personal protective equipment, de-energizing circuits before working on them and testing circuits to verify that they are de-energized. The National Electrical Code (NEC) provides guidelines for electrical safety. Arc flash is a dangerous electrical hazard that can occur when a short circuit creates a high-energy arc. Arc flash can cause serious burns, injuries, and even death. Electrical equipment must be designed and installed to minimize the risk of arc flash. The NEC provides guidelines for arc flash protection. Electrical inspections are performed to ensure that electrical installations comply with the NEC and other applicable codes and standards. Electrical inspectors are responsible for verifying that electrical work is performed safely and correctly. Electrical inspections help to prevent electrical fires, injuries, and other hazards.